Hi, I'm David Bock, and I'm the director of LoudounCodes, a nonprofit in Loudoun County, Virginia, teaching supplemental and extracurricular educational material for computer science in Loudoun County's K-12 schools. This week is Computer Science Education Week, and I'm often asked by parents things about what their kids learn in school. Is it really possible to teach a third grader how to code? What do they do anyway? And I'm going to do a series of videos answering those questions, but first I wanted to introduce a few topics to you. First of all, there's the topic of computational thinking. And parents will often ask, well, how is that different than normal thinking? What is my student going to do? And we'll get into that. Once we have some concepts of computational thinking, students can learn computer programming. And computer programming feeds into both computer science and software engineering. And I'm going to briefly go into what these four topics are, and then future videos will go into this in more depth. Computational thinking, simply put, is puzzles. If you have anything that is hard to solve but then easy to check, that is a perfect example of something that we do in computational thinking. In fact, that's actually a branch of one of the complexity of topics that we deal with in computer science. Mastermind, which is on screen, is a great example of that, as are even things like Battleship and Connect 4 and a lot of other games like that we'll talk about in terms of computer science as well. But computational thinking breaks down into several different categories. When we're solving a problem, what's the data we collect about it? How do we decompose the problem into something that we can think about in smaller parts? How do we realize that this problem is similar to that other problem? And how do we recognize those patterns within those problems? And then finally, how do we use our intelligence to come up with an almost mechanized process, an algorithm by which we can solve that problem? Those are the aspects of computational thinking, and we'll be doing a video on that shortly. Once we have that ability, we can talk about computer programming. And computer programming is what most people think about when we think about programming and curriculum in computer science. It's learning a language. Language like Java is commonly taught for students that are taking the AP exam. We often teach Python or a language like Scratch to younger students. It's really anything where you have the language, the syntax, the concept of variables and types, computers doing math and if-then-else statements, and the kind of logic that's necessary to solve the computational thinking examples that we work up in the first topic. Then by high school, we're able to really teach some topics around computer science. Computer science is typically thought of as one of a branch of mathematics, and that's true, although not the kind of mathematics you might normally think of. We delegate all the arithmetic to the computer in this. Here we talk about things like combinatorics and statistics and all kinds of mathy topics like that, advanced math. We talk about data structures. That is, what's the best way to represent that problem in the computer's memory with the tools we have. That's where, like, Chutes and Ladders is a great example. Once you can program a computer, building a simulator for Chutes and Ladders requires a lot of knowledge of things like data structures. There's advanced algorithms, that is, solutions to problems that have been discovered over the years that are so worthy of knowing we teach them to students as like canonical examples in that problem space. Then there's the notion of algorithmic efficiency. How hard is that problem going to be for a computer to solve? There are problems that we can solve the simple case in a few seconds, but to solve the general case, it might not finish in our lifetime. So we need to consider how easy is it, or how automatable is the solution, how practical is that solution. Then there's even the notion of what is computable. And this really branches from mathematics out into a topic of philosophy. Are there problems that are provably non-computable? And yes, there are. And we get to that subject as well. And then finally, what most people think about as a career path in this sequence of topics is software engineering. This is typically where I have my most experience and where our students will have a career path if they, everybody wants to work for Google or Facebook or Microsoft. This is typically what we think of. And they apply the other topics that we just talked about to various degrees for solving business problems as people work together in a team, design human interfaces, work with specialized skill sets. We manage the complexity of the problem versus the complexity of the software. Taxes are a great example of this. The tax code is complicated. We don't need to make that more complicated by the language choice and software design that we throw in on that. So we need to manage that kind of complexity that we bring to the solution. There's all the notion of the configuration and change and release management. And if you've ever written like a term paper with several other people, you felt this pain where you have to change articles and you can tell voice of writing style. We need to, as software engineers, work together to resolve that kind of stuff. And of course, there's the operational ongoing support of the system is up and running and it's on the web and people need to hit it and expect it to be up and running. Those are the fields that we talk about in software engineering, and there's a lot of tooling and a lot of knowledge that goes into that is different than the other topics. In fact, computer science and software engineering are very different career paths. So these are the 4 topics that we typically think of in terms of our curriculum as we teach people. And I'll be doing videos on examples of all of these within Loudoun County's curriculum. Thank you very much.